Welcome, fellow explorers, to Project Makirraji. In this monumentous episode, we will see how the creatures of Makirraji's oceans clamber onto land. Dry land is a harsh and hostile habitat for creatures who don't possess the specific adaptations needed to survive there. As of now, dry land is nothing but a barren wasteland. With no food in sight, life has no reason to venture onto land. But that may soon change. Perhaps a clade of Diapergo may find themselves in the intertidal zone of Kyphora. Makirraji's moon is not as large or powerful as Earth's. Nevertheless, Makirraji's tides may still have a significant effect of the creatures that live in the intertidal zone. The Diapergo that find themselves in this zone may often be exposed to the open air and the blaring sun. They may solve this issue by producing a slimy substance that coats their bodies. This slime will be replenished once the tide returns. Another problem faced by these plants is their posture. Once the tide recedes, these plants will have no support and thus won't be able to photosynthesize as effectively. They may develop a tough outer skin that keeps them up straight and has the added benefit of retaining water. However, their leaves may not have this tough skin. This allows them to release and take in needed supplies through specialized pores in their leaves. These pores can be open and closed to prevent water loss. Seeing as the leaves don't possess the tough skin that the body does, they are held up by water pressure. This presents a unique opportunity for the plant. They are able to pull water out of the leaves, causing them to sink into the more well-protected plant body. They may do this to avoid especially hot days, to replenish the mucus coating on the leaves, or to avoid future predators. The last problem these plants need to solve is reproduction. To overcome the challenge of reproduction in air, these plants might evolve a unique strategy. Unlike in water, air is a less effective medium for carrying spores. To increase the likelihood of gamete union, these plants may release only male gametes, while keeping the female gametes on a specialized stalk. This would allow for more targeted dispersal and increase the chances of fertilization. We'll call these plants the Terrategro. Species range from 1.5 to 2 meters tall. Another creature that may be found in the intertidal zone is the Sabascosta. When the tide recedes and the pools these creatures find themselves in begin to dry up, these creatures can use their legs to crawl to another pool. Over time, the Sabascosta with the strongest legs may be more successful. These Sabascosta may begin to venture further inland in search of food. Seeing as there are no other land animals at this time, these Sabascosta wouldn't face any competition or predation. This may incentivize them to leave the intertidal zone and become full-time land dwellers. However, these creatures will face a few key challenges when transitioning onto land. The first of which being breathing. Its aquatic counterparts breathed through a set of holes on their posterior. In the land-dwelling Sabascosta, these holes may lead to 2 lungs. The lungs will be fitted with ridges and bumps to maximize surface area. They may develop a set of muscles that push against the lungs, allowing them to pull air in and out. This form of active respiration is quite efficient. Another challenge they may face is dehydration. If these creatures stay out of water too long, they will dry up and die. To avoid this fate, they may evolve a thick leathery skin, allowing them to venture out of the water for an unlimited amount of time. The Viata and their descendants had many receptors on the tips of their tentacles, which they used to sense their environment. In the land dwellers, these receptors may form their sense of smell. In order to support themselves on land, they may develop a hydraulic skeleton, pushing and pulling blood through the legs. This form of support may work, but it will restrict their maximum size. However, there is still one tie to the water that these creatures have to break to become full-time land dwellers: reproduction. Their eggs must still be laid in water. To solve this problem, they may develop a soft leathery outer casing. This approach allows the egg to be more flexible while still retaining its contents. These creatures may tend towards a reproduction strategy referred to as R-selection. In this form of reproduction, the female lays many eggs in the hopes that at least a few will survive. This strategy will allow these creatures to quickly spread across Kyphora. We'll call these creatures the Pinnarii. Sizes range from 18 to 14 centimeters long and live for up to 5 years. As the Pinnarii begin to spread and diversify, predators may follow. Perhaps a group of Verarella that preyed upon the Sabascosta may follow them onto land. However, they may share many of the challenges the Pinnarii faced before them. Their ancestors already possessed a skeleton which may aid in their transition to land. Unlike the hydrostatic skeleton of the Pinnarii, these creatures' skeletons are made of hardened minerals. This skeleton will allow them to get much larger than the Pinnarii. Their ancestors breathed through gills near the first set of 3 fins. As they transition to a land-dwelling lifestyle, they may internalize these gills into 2 lungs. However, these lungs are quite different to ours. These lungs have 1 opening and 1 exit. Similarly to the Pinnarii, these creatures may possess specialized muscles to pull and push air through the lungs. These muscles may operate separately from one another. This means these creatures pull air into the lung through one tube and exhale through the other. At the same time, they pull air into the lung while exhaling, allowing them to have 2 batches of air in the lungs at the same time. These creatures may develop a pair of olfactory receptors around their air intake pipes, forming their sense of smell. To avoid dehydration, these creatures may evolve a thick layer of leathery skin, similar to that of the Pinnarii. Reproduction in this clade may take a slightly different approach. After mating, the female will lay eggs. Unlike the eggs of the Pinnarii, these eggs have a hard outer shell which keeps the eggs moist and protects them from threats. However, these eggs are much more brittle than those of the Pinnarii. The female can lay anywhere from 25 to 50 eggs. This means this clade is in the middle of the spectrum when it comes to R and K selection. We will call these fascinating predators the Sequidata. And now we can travel across the world to see what land dwellers have emerged on Nymphos. The Lungofogile of freshwater may find themselves in a unique position which may result in them becoming full-time land dwellers. As these plants carpet the rivers and lakes of Nymphos, they may start growing out of the water, seeing as there is very little space left. They wouldn't grow too far, however, as they would still be mostly aquatic. But as they specialize for a land-dwelling lifestyle, they may evolve a hardened outer layer around their main body and gas sacs. This would allow them to grow quite far inland, but they still have a few challenges to overcome before they can become full-time land dwellers. When it comes to reproduction, these plants have evolved a remarkable strategy. Each gas sac is either a male or female receptor. Male gas sacs produce male gametes that will be released through a small hole at their tops. The gas will push the gametes into the air and allow them to drift much further. Female gas sacs grow large stalks around their tops to catch these male gametes. Once the sac has been fertilized, it will produce seeds at the base of the gas sac. The seeds will then be launched out of the gas sac, allowing these plants to disperse quickly and effectively. This strategy also minimizes the parent plant's competition with its offspring. We will call these organisms the Artanagile. The Artanagile represent a prime opportunity for any creatures willing to venture onto land. The cicada may be these creatures. They may use their strong tentacles, once used to hold onto rocks, to pull themselves out of the water. At first, they would only be able to survive out of water for a short amount of time. However, as they specialize for this lifestyle, they may develop thick leathery skin. This skin would offer greater protection and keep them from drying out. These creatures' most striking adaptation is their legs. They boast an upright posture with 2 legs. This configuration is quite complex, and thus it slowed their transition to land. Their legs and the rest of their body is supported by a simple skeleton made of a flexible polymer. This polymer allows their skeleton to bend in and out of shape in ways our skeleton doesn't allow. However, their bones are still at risk of breaking if they are put under too much pressure. As they specialize for an increasingly land-dwelling lifestyle, they would need a way to breathe air. The 2 breathing holes common to all Viata may become part of these creatures' lungs. Interestingly, these creatures' large stomachs may be split. The main stomach is used to process food, while the split-off section may become one giant lung. The hole these creatures use to pass water may become the hole which they use to exhale. This means these creatures draw in air through 2 tubes, and after it's processed, it exits out of one larger central tube. They may also evolve a set of olfactory receptors around their intake tubes. When it comes to reproduction, these creatures employ a unique strategy. They may grow a thick leathery shell around their clutch of eggs. This shell may function as a sort of ootheca. The parent will stick this ootheca to an Artanagile and leave. Once the young hatch, they can feed on the Artanagile, giving them an early energy boost. We will call these creatures the Pestanta, and they will be the first terrestrial animals on Nymphus. Another clade that might find a home on land is the Iterola. These creatures may be drawn to land by the numerous Dead Sea animals that litter the coasts. At first, these creatures may haul themselves out of the water to feed for a short amount of time. As this behavior becomes more specialized, their fins may become small flexible legs. These legs would be powered by a simple hydrostatic skeleton. This adaptation would allow the Iterola to move on land much more efficiently. To aid in locomotion, their tail may become a flat, broad sort of paddle. They would use this paddle alongside their muscular tail to slide through the muddy coasts. These adaptations will allow the Iterola to make the full transition to life on land. But why would they do this? You see, the oceans are full of life and competition, but land is sparse and full of opportunity. This would incentivize some Iterola to take up a full-time land-dwelling lifestyle. But first they need a way of breathing air. Their ancestors breathed through gills on their underside near the first set of 3 fins. These gills may be moved to their sides for better access to air. They may also be internalized, forming 2 lungs. The lungs are pumped by 2 separate hearts. These lungs may develop a fractal-like internal structure to maximize surface area. They may also develop olfactory receptors near the lungs opening. They also need a way to stave off dehydration. For this, they may initially develop a thick leathery skin. But as they specialize to move further inland, away from the muddy marshes and into drier habitats, they may develop a new type of skin. They may evolve scales. These interlocking scales would provide protection and keep them from drying out in the harsh sun. As they move further inland, they would need a new form of reproduction. Instead of laying their eggs in the water as they used to, they may now lay their eggs in a thick leathery shell. The shell would be comparable to the skin of a cow. The egg would be filled with water and a large yolk. When the young hatch, they are fully independent and are equivalent to smaller versions of the adults. We will call this omnivorous clade the Flessodola. And so, we witness the dawn of a new era on Makirraji. From humble beginnings, life has ventured onto the barren lands, transforming the desolate landscape into blossoming ecosystems. The Terra Tegro, Pineri, Sequidata, Artanagile, Pestanta, and Flessodola, these pioneers have paved the trail, their adaptations and innovations paving the way for countless organisms to come. As we look upon the creatures that have conquered the land, we cannot help but marvel at their journey. In the next episode, we will witness these 6 pioneers fill every niche available, creating ecosystems teeming with life. As they diversify and adapt, the once barren lands will be transformed, setting the stage for a future filled with endless possibilities. A huge thank you to all the artists on Discord who made fan art for this episode. Your contributions to this project are invaluable. If you want to join the Discord to chat, make fan art, or even get access to some upcoming Discord exclusive content, then you can find the link in the description below. Thank you all so much for watching. Don't forget to subscribe, like, and share your thoughts on these incredible creatures. See you in the next episode.